So this is my project on pre-engineering projects, and these are mini projects that can be incorporated either into a pre-engineering curriculum or an already existing curriculum, and they target STEM components. So again, these projects came from the idea of wanting to create a pre-engineering curriculum in my school to give students opportunities to see coding and robots and 3D printing and experience all of these pre-engineering concepts. And so what I did was, instead of creating the curriculum, I composed a bunch of different pre-engineering projects that could be implemented into some high school's classes, so that way students could gain the exposure needed to be college and career ready, which is where our Common Core standards are really going towards. So some of the NETS standards that you're going to be seeing in my project are students being able to take an active role in choosing, achieving, and demonstrating their learning goals. Students are also going to be able to use a variety of different resources to construct their knowledge and then produce creative artifacts that lend themselves to meaningful experiences. Students will also be able to develop and employ strategies for understanding and solving problems. Students will be able to facilitate and inspire other students to learn and be creative, and that's also falling under what my role will play as a facilitator. And then finally, giving students those experiences that lead to the exposure needed for a pre-engineering or an engineering path. So my entire project is held on Schoology, which is a learning management system that we use at our school. And so within Schoology, all students have access to this. They can all comment on each other's postings, they can send each other messages, they can even collaborate on OneDrive, which is a Microsoft program or a software program that students can share their work and edit and stuff like that. So these are where all the projects are going to be hosted, and I'll walk you through a couple of them. So this is coding using Scratch, and so there's an introduction that gets students familiar with using Scratch and creating an account. There's also the project information, which is, again, getting them the account and then showing them the task. And then I always have the rubric down here, so that way they can see what is expected of them. There's also a discussion forum in each of these projects, so that way students can post things here and collaborate with one another, but also ask each other questions. And then finally, I have a project reflection at the end of each project, and it's going to be a video reflection, so or a short reflection paper, whichever they prefer. And the purpose of this is so that they can really reflect on what they've done. So their likes and dislikes, what would they have done differently, how might they have modified, things that they've learned, and different obstacles that they overcame and how they overcame those obstacles. So that's really the layout of each project, but each project is a little bit different. So we also have coding using Python, which is very similar to the Scratch one, and then we have two 3D printing projects. And in this 3D printing project, students again, there's instructions on how to set up an account, and students can choose any topic that we've done in physics to print something in 3D. They have to program it that describes the content and shows their understanding of the content. Students can also, in my pre-calc class, 3D print conic sections. So there's the project format for that. I also have a Makey project where students can I'll open this up, students can actually use Scratch to code their own video game, and then they're going to use the Makey to create their own game controller that goes along with the Scratch video game. Another project that students can choose from is Sparky being an obstacle course. Sparky is a robot, and students can create their own obstacle course and then have another team try to get through the obstacle course using Sparky. So again, all of the information needed, the rubric and everything is right there. Lastly, we have these Arduino projects, and there's tons of different Arduino projects, and I've actually included a link so that they can choose which project they'd like to do. And the Arduino is really just another type of software that allows students to build all of these interactive objects and digital devices that can control things in the physical world. So that is a glimpse of my little mini projects for an engineering course, and I feel free to come in and explore them.